Hello, once again, my name is Slaven. You're watching Math Classroom channel for learning math. Exponentiation with fractional exponents, so-called roots, is today's subject. Okay, let's do some math. If we write something like this, we write 2 on power of 1/2. Okay, 2 is base and 1/2 is exponent. We can transform this exponential form to root form. Okay. All of these are mathematical background rules of the game. The game is not football. The game is called exponentiation with fractional exponents, so-called roots. Okay. Rule number 1. Exponent versus root. On the left side we have exponential form, and on the right side is the root form. This is how we transform exponential form to root form. A on m through n is equal, just opposite, n root from a on m. Okay. If we have n root from a on n is basically a. Okay, rule number 2, multiplication. N root from a multiplied by b. This rule is basically splitting one root to 2 roots. Rule number 3, division. First view. If we had n root from a divided by b, this rule is splitting the roots and we have basically 2 roots. N root from a divided by n root from b. Okay. View number 2. This is practically the same, but here in a game are fractions. Okay. N and n root from below the root is fraction. And now one root we can split in 2 roots, in upper root and lower root, numerator and denominator. Okay. Rule number 4, power or exponent. N root from a on power of m. Basically, exponent goes below the root. Okay. Rule number 5, double root. Root below the root. Okay, m root from n root a. What rule is this? This rule says basically we can change places of roots. M root from n root from a is equal n root from m root from a equals, these 2 roots can change places and we can construct only one root, that is m multiplied by n or n multiplied by m. This is here. Okay. Extraction. Rule number 6. Extraction. If we have a number or variable in front of the root a, and this goes below the root, goes on power of n, power of the number of the root. Yes, this is it. Okay, all roots that don't have a number are practically second root. If we have something like this, second root from x, number 2 that is saying that is the second root is very uncommon. Common writing of second root is practically this. You will rarely see number 2 here. Rarely. Okay. Let's do some application of these rules and do some examples. Example number 1 is here. Third root from 5 plus second root from 3. Okay. What can we do in a case like this? We can transform this to the exponential form. 5 on 1/3 plus 3 on half equals, here, what can we do here? We have here practically different bases and different exponents. We can't do nothing with this. The result is practically the same as beginning. Third root from 5 plus second root from 3. Okay, and this is the final solution. Okay, let's do the second example. Second root from 3 multiplied by third root from 2. Here we have base is 3, base is 2, exponent is 1/2, exponent is 1/3. 3 on half multiplied by 2 on 1/3. Okay, what can we do here? We can't do nothing. Different bases, different exponents. Result is practically same as beginning. 2 root from 3, second root from 3, and multiplied by third root from 2. This is the final result. Okay. Third example. Third root from 2 divided by third root from 6. Okay. Here we have same roots, different bases. What can we do? We can apply rule number 3. Yes, we are going from right side to the left side. Okay, we can write something like this. Third root from 2 divided by 6 equals third root from 2 through 6. Okay, equals third root. We can divide this by 2, divided by 2, we have 1/3 below the root. And what can we do? We can apply the third rule in the case of the fractions and dismantle one root in 2 roots. Third root from 1, third root from 3, and result is 1/3 root from 3. This is the final result. Okay. Okay. For homework, try these 3 examples. 1, 2, free. Try it for yourself, then watch the clip. Thank you, that would be all. If you liked the video, hit the like button, hit the bell, subscribe. See you soon, bye.